Basic components of variational autoencoders, VAEs. Let's start with the basics. What even is a variational autoencoder, or VAE? At its core, a VAE is a type of neural network that learns how to compress data, like images, into a smaller form and then reconstruct it. It has two main parts. Encoder. This takes the input and compresses it into a smaller, hidden representation. Decoder. This tries to reconstruct the original input from that compressed version. But unlike normal autoencoders, VAEs don't just memorize. They learn a distribution. This helps them generate new data that's similar to what they trained on. Architecture and training of VAEs. Now, let's talk about the structure and how we train a VAE. The encoder doesn't just output one value, it outputs two, a mean and a standard deviation, defining a probability distribution in a hidden or latent space. From this distribution, we sample a point, and the decoder uses that to recreate the original input. Training a VAE means adjusting all the weights so that the reconstructions are accurate, but also so that the latent space follows a clean, normal distribution. The loss function. How does a VAE know if it's doing a good job? That's where the loss function comes in. There are two parts to the VAE loss. Reconstruction loss. How close is the output to the original input? KL divergence. This measures how different the learned distribution is from a normal distribution. We want both to be small, accurate reconstructions, and a tidy latent space. Latent space representation and inference. Now this part is cool, the latent space. This is the compressed hidden space where your data lives after encoding. What makes VAEs special is that this space is continuous and meaningful. Similar inputs are close together in latent space. That means we can do cool stuff like interpolation, smoothly morphing one image into another. And since it's probabilistic, we can also sample from it to generate entirely new outputs. Applications of VAEs in image generation. Finally, where do we use VAEs? They're super popular in image generation. You train a VAE on a dataset, like faces or handwritten digits, and it learns the underlying structure. Then you can sample from the latent space to create new images that look realistic but never existed before. VAEs are also used in anomaly detection, denoising, and even music generation. Subscribe to our YouTube channel. Thank you.